next Friday. This is I'm starting a bit in advance. If you're watching this on YouTube later on, you can skip 15 minutes ahead. I'm not editing the videos or, just I don't have a lot of time, so I just present the things that I have, and if you need more condensed information, then it would be great if someone takes all the info that I give out and makes it a blog post or something. So yeah, welcome. I'm gonna wait for people to join the stream. So usually it takes about 15 minutes. And yeah, just for today, I'm going to present deploying Terraform with NixOS. We're going to look at how Terraform works just quickly so you get an idea, and then how it applies to NixOS. And once we're done with that, we're just going to compare it with NixOps as well, because it's a popular solution. And once we're done with that, I'm going to open the floor to questions and also probably reply to questions during the presentation. And also start looking at what people throw at me in the stream. All right. So here's the page. It's going to be linked in the description. Be right back. Hi. Welcome to the stream. I haven't seen you before. So I guess, I don't know if you missed it, but today we're going to talk about deploying NixOS with Terraform, do a little introduction to Terraform so you know what it is, then deploy Terraform NixOS with Terraform, and then finally compare NixOps and other solution to this. It's going to be quite intense. And if you have any questions, feel free to ask. We start in 5 minutes. I'm just waiting for people to join the stream. So this week, I found a few things just as a filler in the meantime. I didn't know this project existed. It looks quite cool. Modules to help you handle persistent state on systems with ephemeral root storage. So this is a NixOS module that you can use that mounts your root as a temporary file system. And then that way you can declare which directories to keep between the boots. So I think that's taking Graham's idea that he promoted a while ago and making it available for everyone, which is quite cool. Yeah, exactly. It's funny because I'm managing the Nix community organization and I didn't know this existed. Yeah, I think this should be the default, really. Maybe someday in the future. Like, how we manage state on NixOS is still very much, there's some state in this folder, and it would be nice if we had a bit more, just control over the state. So that's it. Then I did some pull requests on DIRNV this week. I added this new feature, source env if exists. So often people use source env, and then if there's an env_rc.privates, so you can override the default of the project. So this handles this use case more nicely. What else? Oh yeah, this was a fun problem. So in DIRNV we stat the files to see if the env_rc exists, and we do it from the current folder up to the roots. And there was a bug with SSHFS where the file system returns true if you start the file, but then when you try to open the file, it doesn't exist. So now I had to open the file every time, which is not great, but it's a workaround. Hey, hi, Yomatsu. We're starting in 3 minutes. So I'm just talking about what I did last week in the meantime. I also made this PR. I don't know how interesting it is, but so I noticed in Next packages we have some packages that put the bash completions in that location and others in that location. So this PR is about unifying it to this place, basically. And yeah, it's just a manual task. I think in the long term I want to add a post install check so that this folder gets denied, basically. Any PRs you did this week that you thought were interesting? Yomatsu, you're new here as well, right? welcome. So the format here is a bit free for all. I think I'm just trying things out. I don't know what I'm doing. And yeah, I like to show things that I learned and share the information. And I don't have enough time to write blog posts and things like that, so I'm just using Twitch to to show things. So I hope it's useful, and then once it's finished, I upload it to YouTube. And again, I don't have the time to do edits and things like that, so it's pretty raw. All right, I think we're okay. 1 minute. All right, let's do this. Are you ready? I think it's going to be quite intense, but we'll see. I think I need to destroy. All right, so what is Terraform? Just a sec. I spent 3 hours today preparing this, but it's still very much raw, so we'll see. Alright, Terraform. Terraform is a way to handle resources on the internet. It's basically a similar idea than Chef, Puppet, or Ansible, but it's only applied to cloud resources. And the overall mechanism is you have like a binary that's like an engine, and then you have resources. I don't know if the drawing makes any sense. So these are provided by a provider. And a provider is like a plugin that maps to a specific thing like Google Cloud. And each of these resources, they map to one instance of a cloud resource. So it could be like a VM or like a firewall config. It could be a disk image. It can be many things, right? And each of these are like little CRUD interfaces. So if you look at the implementation, they're going to have like a create function, update, and well, it should be read and then delete. And so you describe this using a language called the Terraform language, or also HCL. And you describe each of these resources, and then you run the engine and it applies it to the cloud. And it creates the resources, so you have like counterparts in the cloud. And I'm going to show you the syntax and everything, so it's going to make more sense. But overall, I think what I want you to get here is you have this engine. Yeah, we need to talk about states after. So this is actually a distinction I wanted to make compared to Chef and Puppet, is that Terraform has this engine here. It works on 3 things actually. When you do a Terraform apply, which is the mechanism you use to enact change into the cloud. So this is the cloud, right? This is my drawing of a cloud. And Terraform, the engine, it looks at a thing called the state. And so it looks at the code. It looks at the state and it looks at the existing resources in the cloud. And then it makes a plan, a decision of what changes to apply. And it could be many things. For example, the first time you apply, it's gonna find no resources in the cloud and no resources in the state. So it's going to create the resources in the cloud and then record the last view of the cloud into the state. So it's like it reads, it creates, and then it records. And the state is the last known state that you have. It's the view of the cloud that you have from the last apply. And now if you go, like, let's say you have a rogue sysadmin that goes and it changes the resource here, and you do again an apply, you will see that Terraform will find that there is a difference between the desired state and the actual state, and it's going to create an update to the resource. Or for some resources you cannot update and it will delete and recreate a new resource in place. Alright, so let's see how it shows in practice. Let me just check that you are seeing. Yeah, that's pretty good. Okay. Alright, I have a setup with my microphone that's not great. Okay, so I'm just gonna in Terraform you have a folder contains all the Terraform files and it's called a module. So you group all the .tf files that you see here in this little demo repo that I created are just they're just going to be all loaded and then considered for the Terraform apply. So for now I don't want to set up the auto scaling, so I'm going to move this out of the way. I don't want the boot image either. So I'm just renaming the extension so Terraform doesn't recognize it. Alright, so we're starting with just a main.tf. And here you already see that is the syntax of Terraform. And there's a few different things that you need to see. The first one is the provider. So you can create instances of a provider. A provider is a module. A provider is a plugin. And you can load multiple instances of the same plugin. For each provider that you initiate, there's actually a gRPC server run that's started in the background on your machine during the Terraform apply. So it's good to know, because if you start 20 providers, then you have 20 little Go programs running. So here it's going to use credentials that are inherited from the environment. You can also pass some keys. Typically here you would pass the credentials or like the details of how to connect to the specific cloud provider. Or it could be a database or some other resource types. Then here we have locals. So they're like local variables that you declare. We have a special type of resource called data. Data resources are not, they don't create any change. They can only output some data, basically. So it's a way to query the cloud. And here, we are going to deploy on Google Cloud, and there's a default network that is pre-provisioned when you create your project. And so we just reuse that instead of creating a new one. But we still need the information about it. Here we can see that's the first resources that we see. Here we declare a new compute firewall. The goal here is that we will open the port 22 and 80, and we want all of the source tags. So I'm not going to go all in the details, but basically here we create this resource. These are the attributes that we want to set. So now let's see if we do Terraform. The first thing you have to do is Terraform Init. This is going to initialize the providers that you declared, and also load other Terraform modules, which is something I didn't mention before, but it's basically other folders with some Terraform code in it. So these are reusable components that you would code. All right, so we're initialized. And if we do a Terraform plan, here you see it found that there's one resource that needs to be created. Hey, Wilkins. We're talking about, I'm doing a quick intro on Terraform, and then we'll look at how to deploy with NixOS. So here the plan is something you can use. It's useful to see what it's going to do. Sometimes, it has some critical, if it changes some things, it could create availability issues. So it's good to have a view of what is going to change. Here I rerun the same command, but instead of plan is apply. It does the plan again. And if you say yes, now it's going to enact the change into the cloud. So if we connect to, while it's applying, we go to the console. Now we go to firewall. And here we should see this resource that's been added. Oops, wrong account. Alright, so we have this new Terraform Nexus demo. And we can edit it using the cloud, for example, the console. So if we do that, and now we do apply again. Here you can see it detected that there's a change, and it proposes to update in place the resource with the desired state. So if I say yes, it's going to revert the change that I just did. So it's quite useful. Any questions so far? All right, so now let's talk about the states. As you can see, there's this file that has been created, and this file, and basically this is the current generation, or like the previous generation, and then this is the previous generation. And it's just a JSON file that contains all the resources that we created. Hey Kelly Jack, welcome. And Contrin. Wow, we're already 13 minutes in. I'm explaining how to deploy Terraform. make yourselves comfortable. And so let's talk about the Terraform state for a little bit. So this is actually a distinction between Terraform and NixOps that we're going to see later. But Terraform actually allows you to share the state between multiple machines. The problem here is because this is a local file, if you have a colleague that also does the Terraform apply, it's a problem, right? Because they don't have the record, or they won't have the same record as you have. And one thing that you might notice if you open this state file is that resources actually get some IDs. So in this case, for example, the ID is stable. Sometimes there's no stable ID that you can generate, so you have to generate something random, and therefore it's hard to really share the state, right? You can't import the same resources easily. So Terraform actually has multiple state backends. Here I didn't put any, but you can use where is it? So you have a number of backends that you can use. I think that's it. Yeah. So for example, if you are on Google Cloud, you could use the GCS backend. It has the locking support, so that no two colleagues are going to apply at the same time, which is quite useful. And then it stores this JSON file in a bucket. And you just have to do this, right? Add this instruction here. Obviously, pick a different bucket. And then you're good to go. Another option that's pretty good is the Terraform Cloud. So if you do app.terraform, I think. You can use this one. So here, this is the states for my infrastructure. And you can store basically the state in here. So it's quite common and useful. And this is free, so it's a nice way to bootstrap. Nixstar backend for Terraform. Yeah, I mean, there's some secrets in the state quite often, so you might not want to put it in the store. Alright, so here we've seen, I think that's enough for a short Terraform intro. Then we're going to see more things, but basically it's like Chef or Puppet, but for the cloud, except that it has a state file, so it means that if you remove a resource, it recognizes that it's missing or that it's not needed anymore, and it can remove it. So the first thing that you want to do is have a NixOS image for your machines to boot on. So I'm going to create one here. So this is cloud specific. I was talking about modules before. Here we have, so I created this project when working at Tweak for a customer. And this allows you to create new NixOS images. So you just pass the Nexus Config that you want to have, the bucket name. So you have to store it on a bucket. So we have to create this bucket resource before. And the thing I didn't mention before is actually Terraform is able to order when it creates the resources, it finds the ordering by references. So for example here, because we reference this resource here, it means it's going to create this before it creates this, right? So that's kind of nice. Yeah, you have to be careful with the Terraform. So a good posture is to actually encrypt the states, and there are solutions to do that. So let's take a look at the Nexus config quickly. This one is just very bare bones. It's just we need a bare bones image just to boot the NixOS, and then we're going to apply some more changes on top. So here we include the minimal profile that disables the dock and sound. Basically, you want this for servers. And then we use the Google Compute image, which is going to be used in the module itself to extract the image and then upload it to the Google Cloud. And then here I'm actually adding my SSH key. So this is another topic, is how to handle SSH keys. I don't know if we have the time to dig into this, but just know there are multiple solutions. All right, so we have to do init again. I have an alias from Terraform to TF, just by the way. And then we do TF apply. Here we see that it's initialized this new external provider because it's used by the module. So here we see the firewall was queried. It didn't change, so there's no change for that. But it also needed to do these two things. And this will be created. So here it takes a bit of time because we have to upload a big raw tarball to the GCS. And under the hood, it runs NixOS instantiate to see if there's any changes. And then if there are, it's going to do a NixOS nix store -- realize. So Kelly Jack, you used Terraform before? For how long? It's so weird to talk to a chat, to be honest. I don't know. You guys should try it sometime. Okay, so as you can see, it takes a long time to upload. So you want to make sure it doesn't change that much because, you want to avoid this. Oh, wow. Yeah, same here, like 4 to 5 years or something. So let me know if I miss anything that you think is important. Okay, so it uploaded the image to the bucket here. And now it's declaring this as a disk image. If we go look into Google Cloud, we have a storage here. This contains the image. And the image is actually containing the SHA of the derivation, so we know it's sort of unique. So we don't have to worry about collisions. And then here in the disks, no, images actually. Yeah. It's true that the language is not great. Okay, so here we can see that, the image has been declared. And then from that on, now we can create new images. We can create new instances either directly or using the instance templates. So this, wait, let me just reply to the chat a bit. Can I deploy NixOS on libvirt using Terraform NixOS? Maybe. So there's two conditions, right? Like you need a way to generate the image, and then you can use the deploy NixOS that we're going to see later on, which is generic to all the cloud providers. And you need to deal with the SSH keys and how to handle that. So it could be possible, but it's not supported out of the box, I would say. So, okay, we have the image, but now it's not super useful. It's just, it allows you to boot machines. And now we're going to see two scenarios. The first one is auto-scaling. So when I say auto-scaling, I'm not going to talk about how to scale things or anything, but I'm just going to show you a way where you have a heterogeneous fleet of VMs that you want to run. They all run the same config, and typically they're stateless, so they're like web frontends, and you want them to scale. So what we do here is we create a new Google Compute instance template, which is just a template of the machine config. So we pass the machine type, some disk. I mean, you can look at the details. All the code is available on GitHub. And after that, once you have this template, you can attach it to the instance group manager. And here our scaling is stupid. I mean, it's a fixed size. So we just have 2 VMs running, and that's it. So now if we do Terraform apply, we have some new resources. And then if we go into the cloud here, we should see some instances at some point. So the nice thing about the instance template and the managed instance group is that if a VM gets unhealthy, for example, it will be automatically replaced. So now we have the instance group, and there's 0 instances, and now it starts the 2 instances. And that's it. I didn't put anything on the system config, so it's not super interesting. Typically, you would connect it to a load balancer in front and do some more things. But here I just wanted to show this is how you deploy NixOS on a, this is the old school, you would use packets, Packer. Yeah, I think that's called. So you would use Packer to generate the disk image, and then you would replace the systems with a new image. And so that's handled out of the box using the NixOS module. All right, so that's for the auto scaling. Now let's say you have a pet VM. So that's, for example, your Gerrit instance or something that holds some states. So here you don't really want to replace the VM on every deployment. What you would prefer is something more incremental where the VM is being monitored. So you go and fix it if it goes down. But if you have some new code to deploy, you want to just change your Nexus config, run Terraform, and it should deploy the new code, right? So here we reserve an IP address just so we have a fixed IP. So even if the VM goes down, yeah, exactly. Packer is brittle. It's Packer was a tool to build disk images, and it attaches to you then use Chef or Puppet under the hood, and it takes usually 30 minutes iterations to build everything because it starts a VM, then it runs the provisioning tool in the VM, and then it creates a snapshot. And it's all actually running in the cloud. Whereas here we generate the disk image on the local machine, and when it's ready, we upload it. So yeah, I think it's more elegant, the NixOS approach. And more importantly, it doesn't take half an hour for each iteration. So once we have the IP here, we also reserve a disk. So this is a disk that we can attach or detach from VMs. And that's where we would hold the state typically, right? Like the database information. Now we declare a new single host instance. So again, here the data is a bit like the instance template, right? We have like a machine type. We specify the boot disk. So notice that here we start with the empty boot image that just has OpenSSH running in it. We also have 10 gigabytes for the root volume. And then we attach the extra disk here. And then finally, we set up the network. We set the public IP here. And some more metadata information. This is important here. Lifecycle is a special keyword in Terraform that says, and you can control the lifecycle of this resource. So typically here you would say, if the boot disk changes, meaning we changed the Nexus config or we did a channel update, so it would generate a new boot disk. But we don't want to replace the VM with a new boot disk because we know we're going to deploy the latest NixOS, because NixOS has this property of converging perfectly the config. We have much less issues with dirty VMs, right? So we can ignore this and it's safe. And now finally, here we have this other module that's part of the Terraform Nexus project. Then that's what I was saying, that can be used with libvirt. Because here the only thing you need is the Nexus config as an input, and then a way to SSH into the target host. So we do this. So here it's going to create the instance, start with the boot image, and then once it's up, it's going to apply this module that's going to push the Nexus config of this other module, other system configuration. And then after that, we're good. And then we can do incremental changes. All right, so let's do this. Okay, we rely on the null provider because the implementation under the hood is a bit of a hack. But don't worry, it's fine. So on Google Cloud, if you change the boot disk, it's going to recreate the instance. So you could also have a model where you recreate the boot disk or like the system disk image. It deletes the instance, recreates a new one, and then the like the data disk, it would be detached from the old one and reattached to the new one. So that's also possible, right? Yeah, version 2.1 of the null provider. There's a lot of nothing to do in Terraform. So one observation with Terraform is people think that it's a programming language, which it sort of is. But because you're handling states, I think the programming mindset doesn't apply really well. Like I end up copy and pasting a lot of the Terraform code, which, you know, if you've been taught programming, you would think this is a heresy because you try to keep your code dry. How I clean up garbage from old incremental changes. The module here actually runs the garbage collection after each deploy. So when we did the apply, here it's connected to the VM. It uploaded secrets, so you can actually specify some keys. And then it's run this other command, and it applies the config. And then it runs the garbage collect. So etc is nuked, I think, if you use... I was just mentioning that before, actually. This week I found out the impermanence project. So if you use this project, then your root is mounted as a TMPFS, and you only keep like the directories that you specify. Can I build derivations on host machine and just copy plus realize on the remote? Or does it do it all remotely? Yeah, good question. Right now it's local, I think. So you need a Linux machine actually to deploy, which is one of the drawbacks of this approach. If you have colleagues that use macOS, it could be a bit complicated. So I noticed a bug today which I never encountered before, so I'm not really sure what it is. But on the first deploy, it doesn't actually deploy the services. So I did like one white space change, and you can see here, how does it detect that it has some new code to deploy? It actually runs Nix instantiate, and if the DRV has changed, then it means you have something to deploy. So when I say DRV, this is the reference to the whole system config, right? All right, let's debug this. So on Google Cloud, there's this feature where you can SSH into a VM using some special machinery. Here it's actually provisions an account on demand using PAM. And then here you get the user with sudo access. All right, we actually have Nginx running here. So in theory, if we go, you can all go to this address actually. And you should see Grafana running. All right, so that's the start of a nice config. Like at the moment I'm playing with Prometheus, Victoria Matrix and Grafana, so I want to get that going a little bit more. So yeah, that's it, I think. So let's compare this with NixOps a little bit. So I haven't prepared anything for NixOps, so this is gonna be more in the air. But basically, NixOps doesn't handle the remote state scenario. I think there's a PR open, so it's possible that it will be at some point. But there will be less backends available. So this is actually quite crucial, I think, if you have any cloud resources. Then another advantage is that Terraform is like an industry standard. So actually the cloud providers themselves are going to work on the Terraform providers, meaning you have access to all the latest resources that they keep churning out. So that can be useful depending, if you know that you're just going to deploy VMs, then you can use it with NixOps. I think it's fine. If you're going to need more resources, then potentially Terraform is better supported. So yeah, I think that's quite important. One of the downside of Terraform is you have a seam between the Nexus Config and then the deployment language, which is Terraform. And this doesn't necessarily integrate always really nicely, right? Compared to NixOps. NixOps is like one language for everything. So yeah, I like NixOps. I think like the best thing that we could do is actually create an interface inside of NixOps that is able to talk to the Terraform providers. So because the Terraform provider is just a gRPC server that is introspectable and that could generate NixOS-like configuration on the fly. So you could load your providers and then you could basically get rid of the engine of Terraform. And so here you'd replace this and put NixOps, right? And you still benefit from... This is a little bit like Nix packages, right? Like to recreate Nix packages, you would need how many man-hours? So this is the same for the cloud, right? If you want the providers to be available, you kind of want to reuse these. Is it NixOps you use to control your home lab? Aha, Pulumi uses the Terraform providers. That's smart. For my home lab, I actually do something even simpler. I don't know if you know, but if you do NixOS rebuild, you can do -- target host. and you can deploy to a remote machine. So because I don't have any cloud resources, I just use that to deploy. And you have to pass the config, obviously, but you can say the config can be passed in the Nix path. So you can say NixOS-config. And then other hosts.nix, target or host other host. And then I think it's even smart, like if the target host's system is the same as your system, then it's going to build on your system. Otherwise, it's going to build on the target host. So you can deploy from macOS. So that's it for the demo, I think. Oh, I wanted to talk about some downsides a little bit more. Because I think it's important, like we get these. That's why I like to do videos, because it's messy, but you also get the full picture. Like, I'm not going to tell you this is the best solution in the universe and that there's no problem. So I want you to see also the problems. So one of the issue is, and this is an issue that is shared with NixOps, your memory is going to be proportional to the number of instances of the module, right? Every module is going to evaluate NixOS, and NixOS takes quite a bit of memory. So if you deploy 100 hosts using this method, then you might run out of memory. And so, or even maybe 10 hosts, depending on how much memory you have. So this is a thing you have to keep in mind. Another thing is, you remember I talked about how you can reference resources from one resource to the other. So here the output of this resource becomes the input of this other resource. But that doesn't work really well if you want it to be the input of your Nexus config. So if you want, I don't know, like you have another machine that has an IP, and then you want to add it to the etc host of this machine, or like you have a DB instance with an IP, and then you have your web app running in this Nexus config, so you want to refer to the IP of the DB instance. In that case, you need some workarounds, like bind the database to a DNS entry and then make sure that you use the same DNS name in your config. So you lose like the direct connection between things, which is not ideal. Secrets, I think, are okay, but it could be better. So basically you can pass the keys here, and that's like a map where you say this is the file name and then this is the value. It's a bit less flexible than NixOps. You can't really specify which user is like the same user in group that has access to the secrets. But at least they don't get put into the store, they get uploaded separately. These secrets are going to end up in your Terraform state. So yeah, secrets is a whole topic. You can store them. So one technique is on the process in your systemd unit, you have a pre-start condition where you go fetch the secrets somewhere. And this somewhere could be a KMS entry and a GCS object that you load, and then you decrypt with the KMS. And then you set these secrets from another location. Let's see. Yeah, I think that's it, pretty much. I saw you had Home Assistant on one of your serverless stream. Yeah, I haven't really tried it yet. I just did the enable equal true, but I don't know yet. I'm trying to decide between SSH and Docker Compose, supervised K3s or NixOS for my Home Assistant Raspberry Pi. Yeah, I think it's a good question. I had a discussion with Flokely today about this. There's no clear answer, I think. I'm trying to really make this clear. The nice thing about NixOS is, in my mind, is fairly simple to understand. So if there's a bug, I can SSH into it, do systemctl and journal, and I can pretty quickly figure out what's going on, you know. And there's also a bunch of modules, so depending on what you do, I find that the Nexus modules are more reusable than their Docker or Kubernetes like config usually. But there are a lot of Docker images out there. Depending on the project that you use, they only package for Docker. So you can actually reuse that, which is good. Here you have Terraform you have Terraform and NixOS. So maybe if you have Kubernetes everywhere, then the idea is you just have to learn Kubernetes. But Kubernetes itself is quite complicated. It has a bunch of moving pieces. It adds another layer of complexity on top of, you know, just the system. Like when you're trying to debug, you have to listen. You have to look at, you can't just tail the journal, right? Like you have to look at Kubernetes events, then find the right pods and get the logs of the pod. Except when it's dead, I think it's kind of hard to get the logs. And then you have some issues maybe with different components in there. So I don't know. What's the state of Kubernetes modules for NixOS these days? I don't know. I haven't played with Kubernetes for a while now. Usually when I do Kubernetes, I use GKE or some managed solution. So here's the link to the repo if you want to reproduce what I did. Yeah, so another aspect of Kubernetes is you have updates every 3 months. And when you do an update, it's like in place. So you have your whole stack deployed. And then you're shifting the pieces beneath it, and you hope that it's going to be fine. So actually, like the best thing to do is to create a new Kubernetes instance, redeploy the app on top, and then now you need to manage the load balancing between two different clusters. And if you store the Terraform, the state into the cluster, then it becomes difficult. You know, you need to sync the states between both clusters. So that's why I like NixOS, because it's fairly predictable and debuggable. Child service. I started teaching my 10-year-old kid about Kubernetes. My neighbor called child services. I think just teaching YAML is already a cause for calling child services. Alright. I think FZA Carrier wanted to have a look at his Java JVM thing. So I think we're done with the presentation now. And we're just gonna do some random stuff. So yeah, I don't know if he's around. Otherwise, if you have PRs to review or you want to talk about something. And yeah, see you the January. Thanks for watching. Let's see. You still have your Octant PR. What's the link? Nice. So before, when I was preparing this presentation, I tried to deploy in Hetzner Cloud, and I did a terrible thing where it's running NixOS infect on the machine. So I don't know if you know about NixOS infect, but basically you start your machine. So the problem on Hetzner Cloud is you don't have disk images with NixOS, and there's no way to upload custom disk images. So what you do is you start with Debian, and then you use the script that replaces the system in place and then uses kexec potentially. No, I think it reboots actually, but basically infects the system with NixOS, and then you have a NixOS machine. But it's not completely working, so I had to skip this. Alright, let's see this Octant init at 0.16.0. Yeah, like categorizing is always an open question. Oh, there's a K3OS script that does the same thing. But does it replace the kernel as well? Let's take a look. Oh, okay. So it does OS updates from within the K3S cluster. Yeah, it sounds a lot like Rancher because they were doing the same with Docker, right? Like you could update Docker with Docker, and you had like a host Docker and then a guest Docker. So they like to do sort of Docker and Docker kind of things. Oh, there it is. Okay. Yeah, it's pretty brutal. It formats the partitions. Okay, yeah. I think it replaces. Nice. So I had a notice from Twitch that if I put some music, I'm gonna get sued by the, not sued, but they now checking the videos for our music, so I can't put any music. Wait, this is weird. Okay. Yeah, it's a shame. I don't mind paying, but it's just they don't make it easy, right? Okay, looks good. Are you saying T-Pain is an artist that does some free songs? Yeah, I guess it's a good way to get some recognition, right? But the music industry is kind of rotten. Nice. Alright, I think that's good. We can merge it. I don't know if that's important because it's just at the end of the runtime. It looks like a bug in the application, so it's not a packaging issue. Alright, let's merge this. Nice. Alright. Not bad. Go for it, Sim Scott. Stuts. Pass through the tests. If it's easier to ask live, you can also jump on. I guess we could open a channel over here. Yeah, I haven't used pass-through the test either. Let's have a look. Interesting. Yeah, you can just join here and then we can chat. I will shut the music off for a bit. Alright, I'm waiting.
Hello, hello.
Hey Team Stats, welcome.
Hello, Batten.
Can you hear me?
Yes, I can.
Brilliant. I can hear you too.
Terrific. So I was looking at adding tests for Terraform and its providers.
Mm-hmm.
I saw you added, I believe you added a while back, a package called Terraform Plugins Test, which is effectively a derivation that looked at testing the initialization of the Terraform provider to see if it works.
Mm-hmm.
So quite a neat way of testing the provider. But I was wondering whether this could be moved to using pass-through tests.
Yeah, it's a good question. So it looks like the pass-through test is for NixOS tests, but maybe I'm mistaken. I need to check.
So it also gets evaluated by the CI from. It's primarily used indeed by NixOS, but
yeah, you're right. It could be any type of derivations. It looks like it's mostly used for NixOS tests, but it could be any type of derivation. Now, I haven't used it before, so I don't really know how it's being exercised. I think it like one of the issues when you add the tests that are in the package, then they get it makes the compilation slower for the package, right? So here it tries to externalize it. So for post-install test, I think it's pretty good to use this approach. Yeah, sorry.
That's all right. So I guess as a community, should we carry on to add packages that are meant to be purely there for testing purposes?
Yeah, I think that's a good thing.
Yeah.
Yeah. The only question is, when is pass-through the tests applicable versus the inline tests, I guess. Do you see what I mean?
By inline tests, is that
Like the check phase.
okay? Yeah.
So I think the pass-through tests are a good replacement for post-install tests. Or if you want more integration-like tests, you know, like you start a VM and you run the server, things like that.
I see.
And then the check phase is for basically unit tests, anything that is provided by the project itself, like all make test or the Python test and things like that.
Yes, this becomes a bit challenging with anything that uses a plugging system like Terraform, because where is best to put the test? Is it to make sure that they can be initialized? Is it in the provider itself, or in the specific versions of Terraform?
Yeah, it's a good question. Did we have instances where the provider would not initialize?
Well, it was more to do with the underlying file system structure that Terraform requires for the providers. You might recall the shim.
Let me load the context because okay. Oh yeah. So this would be on the Terraform, I think, itself.
Yeah.
Because
I wanted to move these tests to each, because this is only testing for Terraform 11, and there's 3 versions of Terraform that are in mixed packages. So I wanted to add this specific test inside each pass-through test for.
Yeah, sounds good. So you'd have to basically make this a constructor and then pass the version of Terraform that you want to test in it. Yeah, sounds good. I still don't know how the pass-through tests are being executed, but so I need to do some research around that. But I think generally, there's a move to also move more things into the package side of Nix packages rather than, because we have all this NixOS modules tests, and if we can test things on the package side, then it means it's also applicable for other Linux distributions, so it's good.
By the package side, you mean in the pass-through or as a standalone package?
Yeah, I mean, there's some NixOS tests and then there's package tests, right?
I'm not sure I'm familiar with the package tests.
I don't know. Maybe I'm a bit tired and I'm not explaining properly. Just generally, just putting things in the Nix packages as tests is a good thing.
Okay.
Oh, okay. Ryan says I have to fix the sound. I guess they didn't hear what you were saying. Cool. So, any other questions? Did I answer a little bit your question, or was I completely off base?
No, yes, you have. Thank you very much.
Brilliant.
I will get to work. Thank you. I will drop off the chat.
All right. Thanks. Anyone else wants to join? I need a DJ that comes in and fix my sound, an assistant. All right, I think we're kind of running out of things to say today. Unless you have a subject that you want to bring up. That should be it. Oh, we have another. Let's see. Duck. Update unstable version naming convention. That's a deep subject. I like it. So I don't know if you heard me ranting before, but I'm a big fan of one-to-one mapping between everything. So I have a feeling that this is going to go into the same. Oh, okay. Yeah. So I think there's like multiple considerations to have. One is when you have so here dash unstable is fine, but there's another one which is the specialization. For example, if the package name attaches to the attribute. Okay, let me just restart this. I think we should have the attribute name match the p name in every case if we can. So yeah, that's important. So in that case, if the attribute name is pname dash unstable, then that should be the pname. But if this is just a thing that you want to add to the version, then it should be on the version side. What about nested attribute paths? I don't know. That's a good question. There's not a lot of solutions. You could put a dot in the pname, but then addressing it could be a bit problematic. Although, yeah, actually, I think a dot would be pretty good. So you would get git and tools.git. And then I would maybe encourage people to clean up this git and tools attributes package thingy and put it to the top level. But yeah, GNOME packages, that's something, or Ruby packages. At least, because the problem is down with git and tools. Yeah, I don't know why, like, we have this little word that has been created. There's some packages that make sense, for example, the GNOME packages or the KDE packages, because they're like a universe of their own, right? And they're maintained by the same set of people. Or maybe language-specific packages like Hackage and Python. But yeah, Git is sort of a bag of tools that relate to Git, but they're not managed by the Git project. So yeah, I think, like, imagine you look at your store path and you see the p name is git-tools.git. Now you know where to look for in Nix packages, right? You don't have to guess or grep or whatever. It's just a one-to-one mapping. Yeah. So we could have also like PHP dash pname prefix. That would be fine. I mean, let's say I had like I was super admin. I could change everything and nobody would complain, which is not super realistic, but I think I would do something like, first I would remove a lot of this hierarchy because this is way too deep. So just dump everything maybe to single categories. And taxonomy is a pretty boring topic actually, because there's no one size fit all. We could just copy some other package manager if we wanted to. But more importantly, it should have like the attributes that map one-to-one to the pname. And I have tons of ideas, but I'm just trying to load them right now. I would get rid of top level. Why do we have, for example, let's take Ruby as an example. Why do we have Ruby packages here? Or actually Python is even better because it's done properly in the sense of it's following the conventions in Nix packages. So we have this package here, this Nix file, and basically all it's doing is going into development Python modules and loads all of the derivations here, right? So why don't we have this file as a default.nix in the Python modules folder here, right? So now if I want to create a new package, I can cd into this folder, add a folder, edit the default.nix, everything in one place. But no, we have to split it. Same with, and then in development, you have, for example, interpreters Python. So you have Python here as an interpreter. Then you have build support fetch PyPy, I guess. Or no, not for this language. For some languages, you have the fetcher and build support. And then in development and the language dash modules, then you have the modules there. I'm ranting a little bit. But why don't we put all the language stuff into one folder, right? Alright, I think that's it for my rant. Oh yeah, we would put the docs in the folder of the language. So actually I think like, let's rethink Nix packages for a second. First of all, I think we would have a simple folder. And this would be for simple packages. And the difference is, a simple package is something that you can describe using data uniquely. So here we would have a data.nix or whatever. And this would be basically JSON-like data. So it would turn the thing around and it would say maybe it's a type GNU or whatever. And then the source, I don't know what I'm saying, but it seems like you could turn this upside down, and then at some point something would call the stdn.mk derivation on top of that. So that's my badly explained idea. But so most of the packages would be in the simple, and then for the more difficult ones, you would keep the old system around. What else? Yeah, I think that's it. I have more ideas, but they're not there yet. But yeah, the docs sounds great. Imagine if you go development, Ruby modules, and here you had a readme.md, and it says Ruby modules, welcome Ruby developers. This is everything you need to know to develop in Ruby using Nix. And then it sets like developer environments, packaging, things like live reloads. I don't know. So now if you come, you know, like how to add new packages. So how to do testing. Right, and then you come in the folder, you look at this and you're like, okay, I'm a Ruby developer, so that applies to me. And to develop, I need to do this. No. So I hope this is happening because we have this RFC that was accepted to change the documentation from DocBook to Markdown. So there's an opportunity there to do things properly, I think. Another idea with this simple folder is you would actually have a default.nix here. And what it would do, it would call built-ins that reads there, and then I would get the data here, right? So it just gets the list of simple packages, and then it would do a map attributes. Let's say we have the lib here available. And then lib map, I never remember atch map or map atch. And then call package. Well, there would be another implementation of call package that would be called simple package. And then because it's a map, the key is the file, and the type is the type of file. So you would do something like file, boom. Then you have the data, and here you'd maybe filter out and just keep the folders, right? But now, if you want to add a new package, you just need to create this other hello package. And that's it. There's no more big ass map where we have here. I mean, this thing is a nightmare to manage, right? It's sort of alphabetically sorted, but we gave up on it. So there's multiple It's alphabetically sorted multiple times in the file. Is built-ins redir IFD? I'm not sure. It might be less pure than actually specifying the file explicitly. Would anything live inside the Ruby dir besides the duck and build support? So the Ruby dir would contain all the Ruby related things like build support, fetchers, documentation, all the packages, the Ruby packages. Would we still place a command line, say written in Ruby, under the existing taxonomy? I think there's a case for having package sets and then re-exporting some of the stuff under the top level. So, as from the user's perspective, I don't care if it's written in Ruby or Rust or whatever, right? I just want to use the command line. And so indeed, I shouldn't have to know it's written in Ruby, and I should just know the project name. But you can have the Ruby package in the package set and then re-export it, reattach to the top level. I think we do this quite a bit. I mean, yeah, I don't know if that's a good example, but here we sort of have a package set and then we re-export things in the top level. But we don't bind the package set to the top level, so I don't know if there's other examples, but I'm sure there is. But it's true that most of the time we do this, where we build the temporary package sets, but then we don't re-export this to the top level. I think, actually, now that I think about it, the cabal install, I think, yeah, here you can see cabal install is using Haskell packages and it's re-exporting this to the top level. What do we do with programs tools that are written in different languages? Yeah, so that's why taxonomy is broken, right? Because you always have special cases. So that's why I think we should have like a simple or a common thing. And then when it doesn't fit, then we just fall back to the general all packages, which is going to exist for a long time. But it's still, like, even if we have, let's say, 20% of the packages that are, yeah, we have a dumpster fire directory. But even if we have, let's say, 20% of the packages that are in the simple folder, meaning the updater script could be all unified. We have like a percentage of packages that are very easy to handle. They're just data. If you have packages that are data, then you can write all sorts of scripts that can auto-update. It becomes very easy. So now we treat more and more of Nix packages as a data set. We can use machine learning to automate this. Now I'm going a bit too much in a keyword land, but like the more we can treat Nix packages as data, the higher we can scale in terms of number of packages that we have. And I think that's crucial if we want to scale Nix packages in terms of the number of packages versus the number of humans that are in there, so that we don't burn out. It seems like the best thing to do is not to do politics, but actually move more and more Nix packages towards data. And then we can write scripts instead of politics. Yeah, that's right, Ryan. Taxonomy, because taxonomy is multi-dimensional and folder structures are inherently a tree. And so that's why we're always conflicted about in which folder should we put things. But actually, if we have metadata, then we don't have that problem. Yeah, that's a great point. So yeah, that's my little rant on how to restructure Nix packages. I would love for this to happen. I think what's going to happen is someone is going to figure out how to generate packages description or something, automate this using some form of machine learning. At some point, it can be Nix packages, or it could be Bazel, or some other project. And Nix has a great position right now because of the Nix packages, right? So if we invest into this, then we can still be the lead in the future. You know, I mean, Nix is just a technology, so we don't need to be invested like it's our children or anything. But yeah, I can see how as an industry, we're doing more and more things and indirectly. Like if I look at my GitHub timeline, half of the events that are generated are bots now. You know, bots that update packages, bots that check some security stuff. So, you know, there used to be 100% of people that would generate the timeline in GitHub. And I can see in the future there might be 1% of people. Or maybe we would have a meta GitHub where there's going to be people writing code that directs the bots to work on the repos for you. So yeah, that's the future, I think. All right, since we're talking about changing things, I would like to add a new folder here called services. And service is for network services. So let's say Grafana, because we used that before. So a service is like a NixOS module, except that it can only set things for itself. So there would be also options, and there would be a config key. But the options are things that you declare yourself. So like user, so something like that. And then on the output, we have a standard interface where this would declare a single service, right? So I don't know the details yet, but basically the idea is here you would get a subset of the systemd units where you just declare like the program to start. And the idea is a service should be mountable. So when you do your Nexus config, like that's my configuration.nix. What I want to be able to do is something like import services. And this is a map. And then the key is whatever, like Grafana1. And then import grafana.nix. And grafana2 is grafana.nix. So now I can have multiple instances of a service. And then here it would generate a key. And then I can set the user here potentially. Something like that. I don't know exactly how it would look like. But the important part about the service idea is it's a general interface. And then it could be reused between Home Manager, Nix Darwin, and NixOS. What do you think? Is it still too fuzzy? Alright, I think that's it for today. Alright, I think that's it for today. Alright, I think that's it for today. Thanks everyone for watching. And next week, I don't have anything planned yet, so let me know if you want to discuss about something. Oh, Ryan. System agnostic configuration file generator. Yeah, thanks Tim Scott. Ryan, I will take a look. And yeah, let's keep in touch. I think like it would be nice to have some people on the stream because talking in the void is a bit weird. But if you enjoy it, you know, it's good. All right. See you next week, everyone. Have a great weekend.